All right, good morning, everyone, and welcome. My name is Jan Hofmeijer, and I'm the Vice President for Amazon EC2 Networking and Edge here at AWS. For who is this the first session at reInvent? Excellent. Well, welcome, and I hope it's the first of great engagement, and thank you for being here. I'm thrilled to share with you today some of the innovation in the hybrid cloud and edge computing. I'll discuss how our innovations can help you take advantage of AWS wherever your application needs to run, whether it runs on-premise or at the edge. I'm also honored to have Jeff Weist here with me today. Jeff is the Executive Director of Hosting Solutions at Merck, and he will share how Merck is transforming healthcare innovation by bringing AWS experiences on-premise. Jeff, great to have you here. I'll first provide an overview of our continuum of cloud services that extends from the cloud to the edge, and the breadth of workloads and use cases that our hybrid and edge services can serve. We will then dive deeper into very specific topics that have consistently come up with most of my discussions with customers these days. This includes how AWS experience on-premise can help facilitate VMware migrations with on-premise dependencies that cannot easily be moved to an AWS region. And how you can run regulated workloads with data residency requirements. And then last but not least, we will also discuss our latest geographic expansion of our AWS services so that we can support you globally where you run your services. So let's dive right into it and start with the AWS Cloud Continuum. While many applications can easily be migrated to the cloud, customers are telling us that some of their applications need to be re-architected or modernized before they can be moved. And many of our customers also have applications that have to stay on-premise due to low latency, data processing, and data residency requirements. When we first thought about extending the AWS services to the edge to accommodate these use cases, customers were very clear with us. They asked us, we want the same AWS experience. We don't want a bespoke solution. We don't want something that you build specifically for the edge. We want AWS at the edge. And therefore, that was a key driver for us. They wanted the same reliable, secure, and high-performance infrastructure. When we have a M6 instance in the region, and I put an M6 instance, EC2 instance in your data center, they want that performance to be identical. They wanted the same operational consistency, the same services and the same APIs, the same tools for automation, deployments and security controls, and the same pace of innovation that they experience when running in the cloud. So working backward from these requirements, we became the first cloud provider who brought cloud infrastructure innovation like AWS Nitro system to enable fully managed, truly consistent cloud experience across distributed locations. At AWS, we delivered a continuum of consistent cloud services with various types of distributed locations. The continuum of cloud starts in our regions. And then from our regions, we move to major metropolitan areas and industrial centers with AWS Local Zones, and in locations within 5G networks with AWS Wavelength Zones. Moving on to the edge or on-premise, AWS Outposts extends the AWS infrastructure and service to customers' own data centers, co-location facilities, and edge sites. And to help address complex digital sovereignty requirements at scale, we offer AWS Dedicated Local Zone that can be placed within a customer location. And for these customers who want to integrate with their own environments across AWS, we also have, and non-platforms, we have EKS hybrid nodes and ECS anywhere. And out at the far edge, the AWS Snowball, where you are able to extend cloud capabilities to remote and sometimes rugged environments with no connectivity to the cloud. And with Amazon EKS Anywhere, you can deploy native containers in air-gapped environments. What truly differentiates us from comparable offerings is that you can leverage the same infrastructure, the same APIs, management console, automation, governance policy, security controls for all of your applications across the AWS region, our local zones, on-premise, and at the edge. This reduces your time, your resources, operational risk, and maintenance downtime required for managing infrastructure. There's no replatforming or performance validation needed as you scale your application across these locations. It also streamlines developer workflows and allows customers to deliver new products and solutions to their customers faster. These comprehensive capabilities and seamless integration across environments have not gone unnoticed. And in the latest 2024 Gartner Magic Quadrant for distributed hybrid infrastructure, AWS ranked #1 in 4 of the use cases, including the hybrid infrastructure management, edge computing, assured workloads, and AI/ML use cases. AWS hybrid and edge services are built for virtually every on-premise and edge workload. We already support a broad range of workloads at the edge today, so let's explore a few customer examples. First, multiplayer gaming companies have developed sophisticated automation to deploy and scale their application as close as possible to the user to achieve the best possible performance and latency. Epic Games already run in our AWS regions and have now expanded into AWS Local Zones to achieve down to single millisecond latency for their users that are not located close to our regions. Gaming companies can also leverage AWS Outposts as a solution prior to the availability of a region or a local zone in an area where they have high concentration of gamers. For companies like Epic Games, the AWS Cloud Continuum allows them to deploy to the region, Outposts, and local zones using the exact same game servers, automation, and monitoring. NRI offers secure and reliable cloud-based management services to financial services customers in Japan. It uses AWS Outposts to provide cloud services to mission-critical systems that must stay on-premise due to data residency requirements. With Outposts, NRI achieved a 30% reduction in deployment time for new services compared to traditional on-premise infrastructure. And NASDAQ, we spoke about NASDAQ in the previous sessions last year and the year before. They're on their journey to become fully cloud native running in AWS. And they've now migrated 4 of their North American exchanges onto Outposts using the Outposts racks with support for ultra-low latency, fair and equal access networking. The largest of these markets process over 12 billion in daily messaging. Palo Alto Networks, a global security leader, began deploying their Prism Access service in AWS Local Zones across 5 continents. After deploying Prism Access service on AWS Local Zones, Palo Alto Networks reduced the network latency for their customers by up to 50%. AWS local zones are enabling Palo Alto to also expand geographically their services and at the same time maintain a 5.9 availability. In the telecom space, earlier this year, O2 Telefonica in Germany announced its 5G Cloud Core with a new 5G cloud network built entirely in the cloud, using technology from the European network equipment provider Nokia and AWS. The AWS service used by O2 Telefonica includes EKS for orchestration of containerized cloud-native network functions from Nokia. And leveraging this consistency across the cloud, they're able to deploy the control plane of the 5G network in the region in Frankfurt, and then the data-intensive network functions in Outposts within their network. It is the first time that a major telecom operator is migrating an existing network and customers to a new 5G cloud native network running on AWS. Another example is WeWin Corporation. It's a cloud IT infrastructure provider of high-quality computing and storage products, as well as a rack solution for data centers. WeWin deployed its latency-sensitive manufacturing automation and warehouse management system on Outpost and reduced the deployment time of these systems in a new factory site by 90%. By taking advantage of Outpost as a fully managed solution, it only required an eighth of their original manpower to manage its IT infrastructure. Just a remarkable improvement that they achieved with Outpost. Next, I would like to address an emerging class of edge workloads that has garnered interest across the industries: artificial intelligence and machine learning. Today, our customers across manufacturing, public sector, healthcare, and other industries are already using AWS hybrid and edge services for real-time edge inference of ML workloads. For example, Acton is using Outposts for visual inspection within their assembly lines. We have a government agency that uses Outpost for real-time object detection to prevent smuggling. And we have Apollo Hospital using a Snowball for AI-guided preventative healthcare procedures. While machine learning made it possible to create applications that would not have been possible or impractical through conventional programming, generative AI vastly extends this power, allowing you to deploy applications that can create new content, including text, images, video, audio, or even code. While most generative AI workloads can run in the cloud, some need to remain on-premise or at the edge due to digital sovereignty, data residency, and low latency requirements that requires for processing that needs to happen local. AWS hybrid and edge services support three major categories for generative AI use cases. The first is a customer subject to data residency requirements can remove the PII data and other sensitive information before sending the data to the cloud for training. For example, we're working with a financial services company on a generative AI solution that automates generation of compliance reports. This solution would anonymize personal identifier information on-premise with a small language model before sending the data to a large language model in the AWS region for report generation. Second, you can take advantage of the existing small language models, optimize and tune it with your on-premise company data, and deploy fine-tuned model closer to where your edge inference needs to take place, using GPU-enabled EC2 instances on local zones and in Outpost. You can choose from a P5 instance in our local zones or the G5, G4DN instances in both local zones and Outpost. This helps you minimize latency and comply with data residency requirements, all the while improving your model outcomes. Lastly, you can also implement distributed retrieval augment generation, or RAG, across AWS region, on-premise, and edge locations to improve the accuracy of prompt outcome with sensitive data that must remain on-premise. This slide shows our reference architecture for running Gen AI models in AWS Local Zones or Outpost. These models are fully deployed at the edge with no external dependencies. This architecture can support a range of use cases, including chatbots, summarizations, text and code creation, and complex report writing. The workflow is as follows. A user sends a query to the application server running in an auto-scaling group behind an ALB. The application receives the request and then formats it for delivery to the Gen AI models. In some cases, particularly in summarization use cases, the document will be chunked into smaller sections for delivery to the SLM. Depending on the implementation, the formatted request is sent either through an ALB or a message queue for delivery to an SLM running on a GPU instance within an auto-scaling group. The testing carried out in our labs focus on the range of models running the Llama CPP framework, which provides an optimal environment for running these models. You can further improve the accuracy of your prompt response by implementing RAG that you can deploy in two modes, either in hybrid or in local mode. In the hybrid mode is for those of you who have sensitive data on-premise, but you can leverage the data in the AWS region. In a hybrid mode, Bedrock agents can be configured to determine when to send a prompt to the region versus to a local zone or outpost. If the RAG agent determines that the user prompt needs to be addressed using regulated or restricted data that runs in a local zone or outpost, the RAG agent will invoke a group of actions that are specific to a local zone or outpost, look up the information from the local knowledge bases, and return the response. If local data residency requirements strictly prohibit sending data to an AWS region, you can also have the option to implement RAG locally on Outpost with no dependency on the region. In this case, the tokenization and embedding of prompts, similarity search and question embedding, and the generation of response will take place locally on the Outpost. We have a demo-rich session in Hybrid 318 that dives deeper into SLA model choices and optimization techniques. If you're interested at this, I highly encourage you to go attend that session or to go talk to an expert in the booth. After sharing how we handle diverse workloads across various industry use cases, let's now focus on how you can bring the power and flexibility of cloud directly to your on-premise infrastructure to accelerate in-place migration and modernization. While most workloads can easily be migrated to the cloud, some need to remain on-premise due to multiple reasons. First, application interdependencies. Some workloads need to maintain low latency interconnectivity with on-premise legacy databases and operational systems. Legacy applications often have complex latency-sensitive interdependencies between various applications components. Bringing cloud services on-premise allows you to modernize these legacy applications while still meeting the latency requirements. The second driver is data residency. This is where data needs to remain on-premise in a particular country or state for contractual or information security reasons. And finally, accelerated migration schedule. Some organizations are pressed to rapidly lift and shift from an on-premise environment to the cloud and plan to modernize and optimize over time. The aggressive timeline can be driven by several factors, including the adoption of a cloud-first strategy, the need to optimize software licensing cost, a business decision to exit or consolidate a data center, post-merger integration, or accelerated business expansion into new geographies. In order to meet this aggressive timeline, you may need to integrate cloud services with existing storage systems and databases and leverage current on-premise network configuration as much as possible. Specifically, with VMware's recent licensing changes, many customers are taking the opportunity to rethink their data center strategy and accelerate application modernization with cloud. As a result, we are seeing an incredible amount of customer interest in services like Outposts for VMware workloads that cannot immediately be moved to the AWS region due to data residency requirements, contractual commitments, or application interdependencies. Outposts runs behind a customer's corporate firewall and provides two pathways to accelerate these cloud migrations. First, you can simply rehost. You can easily lift and shift your VMware workloads to EC2 instances on Outpost and run self-managed databases on EC2, either running on Windows or Linux. Your Outpost is connected to the existing on-premise network or your local provider network through a local gateway. Your second option is to replatform. Amazon ECS and Amazon EKS are natively supported on Outpost. This allows you to containerize your VMware workloads and standardize on a single build, test, and production pipeline across AWS regions, on-premise locations, and edge sites, greatly improving your developer productivity. Additionally, you can also modernize your data infrastructure and move to managed databases and analytics services like Amazon RDS and Amazon EMR on Outpost. Over time, as your organization matures in the cloud skills, you can then consider further refactoring some of your applications using regional services that take a full advantage of the cloud scale and benefits of the cloud. So let's look at an example of a rehost customer who did a rehost of their VMware environment. British American Tobacco, BAT, is modernizing every level of their business with a cloud-first strategy. With 47 factories around the globe, they need AWS services at the edge to help facilitate local factory workloads like GMES and Ignition with minimal latency requirements. BAT has chosen AWS Outposts to deliver low latency and resiliency at scale to support their 24/7 operations with Outpost. This architecture diagram gives you an idea of how their critical manufacturing applications are deployed before and after the use of Outpost. You can see how BAT is able to lift and shift these applications directly to Outpost, leveraging the same compute, networking, and database constructs that can be found in AWS regions. With Outpost, BAT benefits from the following. They reduce their cost by 45% by centralizing management, making it easier to monitor and control their resources. It allows them to extend their cloud-first strategy to include workloads that needs to run or remain on-premise. They can simplify scaling by leveraging AWS infrastructure as a service. And what I mean with that is, as they scale up, they can literally just order additional Outpost racks, add it to their capacity pools, and then scale their business out. And they can remove the management and operational complexity of a multi-vendor on-premise infrastructure and software environment. And finally, they can deploy resilient infrastructure designed with redundancy to support mission-critical workloads. Leveraging AWS Region as a cloud-based, they can leverage AWS Region for cloud-based backup and disaster recovery, and they can lift and shift their migration of their workloads onto AWS. So let's now look at an example of a replatforming at a major bank in Latin America. To transform how the bank delivers banking service to its customers, the bank has adopted an all-in to AWS strategy. Since 2020, it has migrated 70% of their workloads to AWS, including their digital channels. Now they're embarking on a mainframe modernization journey using AWS Blue Age, including modernizing its IBM Series 1 mainframe to AWS in the next 3 to 5 years. Migrating directly to the AWS region is made difficult based on a number of applications that need to interconnect with the mainframe system at a latency below 10 milliseconds, including satellite applications running on OpenShift with NoSQL databases. They use IBM WebSphere MQ and an application server layer on WebSphere application server. To de-risk and accelerate their migration, the bank is migrating their applications surrounding the mainframe system from VMware and OpenShift clusters to EKS on Outpost racks, deployed in both their primary and DR sites. They are migrating 1,500 containers and 50 VMs, including 30 of the IBM WebSphere applications, servers, and 20 IBM MQs for messaging to the Outpost environment. This allows them to migrate these applications without having to deal with the risk of increasing the single-digit latency requirement to the IBM mainframe. Furthermore, they are now able to improve operational excellence by standardizing on the same tooling across AWS, OpenShift, and WebSphere MQ environments, such as CloudWatch, CloudTrail, Cloud Tower, Amazon Config, and amongst others. And finally, they are able to implement a consistent approach to automation, governance, monitoring, and auditing model on AWS. So far, we have covered examples of how manufacturing and banking customers can migrate and modernize in place with Outposts. Now let's take a look at an example in healthcare and life science. With that, I would like to welcome Jeff to the stage to discuss how Merck have innovated with Outpost. Jeff, welcome.
Thank you. All right. Thank you, Jan, and thank you for the opportunity to present today. Hope you have a little bit to learn about what we're doing, bringing our cloud environment to our on-prem. For those that don't know, I'm with Merck & Co. Inc. We are a global healthcare company that uses leading-edge science to help save and improve lives around the world. We've been around for about 130 years, and Merck is known as Merck & Co. Inc. in the United States and Canada, and MSD in the rest of the world. A quick little background about myself, so you kind of understand why I'm up here, and hopefully you care about what I'm saying for this presentation. I've been an AWS Customer Advisory Board member for several years now, and I've been dealing with the AWS global regions for about 10 years, focusing on the landing zones, establishing governance, guardrails, and really driving the company to embrace cloud technologies inside our company. About 2 years ago, my responsibilities expanded, and I became responsible for our on-prem environment. So all the things that I took for granted in the cloud, all the things that I didn't have to care about, like what hypervisor are we running? Is my hardware healthy? Am I patching my hardware fast enough? All of those became my responsibility, and they became my problem. As we start talking about how we're leveraging cloud computing on-prem, I wanted to ground ourselves in the strategy of our company. Our goal or our priority is really around accelerating the velocity of change inside our walls to really accelerate the rate at which we can create life-saving medication for our customers and patients. Some of you can relate to this, but three primary areas that we focus on. The first is simplicity. We want to have as simple environment as possible. We want to avoid duplication. We want to avoid reinventing the wheel. We want to make sure that the investments that we're making in the solutions that we're building or the capabilities that we're offering are able to be reused as much as possible. Next is total cost of ownership. We want to really make sure that we're minimizing the amount of cost that it takes to support our environment. Using one of AWS's famous buzzwords, we want to eliminate that undifferentiated heavy lifting. Every dollar that we're spending towards sustaining the environment is a dollar that we're not spending towards our core mission statements. And lastly is transformation. If we want to remain one of the leading healthcare companies in the world, we need to transform. We need to make sure that we're embracing the latest technological advances that are out there and making sure we're modernizing our ways of working. We have a team of incredibly smart engineers, but if we're focusing on sustaining and maintaining the environment, recreating things that already exist, we're not getting the most value that we possibly could and not offering the best capabilities we can to the ones that matter to us most. This is evident inside our hosting strategy. First, we leverage software as a service where possible to minimize the amount of responsibility there, and then we look to leverage the AWS global regions. Today, we host just about everything inside our AWS global regions, from biologics to high-performance computing environments to generative AI. We're even running SAP inside our AWS global regions today. There are another number of other talks at re:Invent this year around some of these capabilities, so I encourage you to check out Merck speaking talks in the catalog. But with all these workloads that we're able to run inside our cloud environment, the public cloud environment, there are still workloads that have to remain on-prem. As Jan mentioned, there are two primary reasons for this. First is around latency. We have certain latency requirements that applications need to be very performant to on-prem infrastructure. And the next is data residency, where we need to make sure that data stays local to certain environments. Our on-prem landscape is made up of 4 different sections or 4 different categories of applications. Several of you may have a similar situation inside your environment. First is our data center business supporting environment. These are the less critical applications. These are the ones that we ideally will be able to move to the AWS global regions, but we're keeping them on-prem for now. Examples for these are corporate tools and just small applications that haven't been able to be moved yet. The next set we have is data center critical environments. And you can see the requirements are growing as we go down the different categories. The data center critical environments, these are our most critical enterprise applications that are running within our walls. Some examples here are enterprise backup capabilities, as well as some enterprise security tools that apply to our on-prem infrastructure. The next 2 categories that we have are related to our edge infrastructure. These are sites that are spread across all the world and are used, are much smaller and used for very specific use cases. These typically have more limitations, largely in regards to networking, where we have limited network constraints that we have to work within. Some examples here are local facility applications that deal with the individual sites that we have. And the last category we have is our edge restricted. These are our most critical applications that we have inside the company. And these are the ones that are typically connected to our manufacturing or research equipment. These have the most restricted networking we have because of the data and information that it deals with. Some examples here would be our MES implementations, our PASX implementations. So knowing that we want to transform and we want to take all of our applications and really modernize the best that we could, we need to establish a good foundation for us. So a few years ago, we started a cloud transformation initiative known as Blue Sky. That's not the blue sky that you're reading in the news right now. This is an internal code name, and I think we had it first. But it's a cloud transformation initiative that was designed to change the way that we work and modernize our operating model and our support structure. We chose to use the AWS global regions for this because all the capabilities that we needed for that foundation were immediately available. We could use the infrastructure as code, CloudFormation, Terraform that was available. We could use all the APIs that were immediately available. We can use the pipelines, and it was software-defined everything, so we were able to take advantage of those capabilities right from the start. That allowed us to focus on upskilling our staff and modernizing a lot of our capabilities. And this was incredibly successful. There's a great talk at last re:Invent talking about all the value that we were able to achieve through this initiative internally. And it really allowed us to accelerate the velocity of change inside the environment. By leveraging these cloud capabilities, we're able to move a lot faster than we've ever been able to move before and really achieve that value that we were looking for in our company. But now that we had the success inside our public cloud environment, we wanted to set our sights on-prem as well. And that's where our next iteration of the Blue Sky initiative came in, with a focus on the on-prem environment. As part of our on-prem initiative, we're leveraging AWS Outposts as our solution in order to take those cloud capabilities from our global regions and deploy them inside our walls. That allows us to take the investments that we've made, the transformation initiatives, and reuse that internally. There's been a number of benefits that we've been able to gain from this solution and this way of working. The first is around reusability. You heard Jan mention this as well, but we're able to reuse a lot of the work that was developed. Because the AWS Outpost solution uses the same APIs as the AWS Global Regions, we're able to leverage the infrastructure as code templates that we created for our public cloud deployments. We're able to reuse the automated pipelines that we've created to deploy our solutions as well. And because it really just shows up as another availability zone inside the cloud, all the automated governance that we invested in managing our global regions, we're able to apply that here. And from a user perspective, it's just another environment that they can use to host their workloads. That really minimized the amount of work that we had to do and really allowed us to use those investments more than we've been able to do before. That leads right into minimal management. The Outpost solution is really a hands-off supporting device. Once we had it deployed, the first device inside our walls, it really just worked. We didn't have to worry about making sure that the hardware is being maintained or monitored. AWS took that responsibility for us. When patches came out, AWS supported those and provided those to our environment. We didn't have to worry about that. And it really just ran. That goes back to the total cost of ownership goal that we had, where we wanted to minimize the amount of that responsibility and instead focus on more value-add activities. And lastly, we're able to use modern architectures. In the past, we're traditionally just able to offer virtual machines inside our on-prem environment. But with the capabilities that the Outpost device offered, we're now able to recommend modern cloud architectures that could be applicable for the global regions as well. We're able to use auto-scaling to immediately spin up another resource as it's needed. We're able to use that for blue-green deployments. We're able to leverage and recommend managed services such as RDS or S3, and even container services like EKS. These are all capabilities that we were not able to offer before, but now we're able to do that through the Outpost implementation. And what's next for us? So we've been very successful using the Outpost capabilities today, but there's two areas that are big opportunities for us where we can expand our usage. The first is around connectivity. The AWS Outpost device is designed to be a connected device where it's running and it's connected to the regions for that management layer and the control plane. As you heard before, we have some of our edge locations that have limited network availability, and if there's a disconnect there, that could present some challenge to some of our workloads. So what we're very excited for is to hear from AWS around additional options for dealing with different network connection scenarios. The next for us is around form factor. The AWS Outpost today is deployed, ours is deployed inside our rack form factor, inside our walls. But some of these edge sites, they have really limited space, very limited physical location where we can deploy additional devices. There is a server form factor that's available today, but because of some of the storage configurations, we weren't able to adopt that as we hoped for. But we're very excited to work with AWS to see what's coming next from a storage perspective to leverage the additional form factors for the device. Overall, though, this has been a very successful journey for us, and it's very exciting to see us being able to take all of our investments that we made inside the public cloud and reuse the vast majority of those inside our walls and see that transformation today. We're very excited to be on this journey with AWS. So with that, I'll pass it back to Jan.
Awesome. Jeff, thank you so much. I should end right there. That was a great presentation. Thank you, Jeff. I think just to reiterate a few things that Jeff said, I think the fact that you can now take what you've done already in the region, deploy it on-premise, and then have the option anytime in the future to start moving those back into the region, that flexibility, that's one of the key values we want to offer our customers, right? So that you can start the migration, you can start the optimization on-premise, and then over time, the systems that can move into the region, and that becomes seamless. You've already cloudified your applications. So thank you for that. I really appreciate that presentation. And we always say at AWS that we are customer obsessed. You've heard the stat that more than 90% of all the features we built comes directly from customers asking us. Like Jeff, I think you listed a few things there in your talk about things you would like to see from us. And one of the things you mentioned was third-party storage systems from NetApp. And we recognize that as a common requirement across many of our customers. asking us, can Outpost integrate with my existing storage solution? So I'm excited to announce that, or to share with you, that we've launched a new Outpost third-party integration with NetApp and Pure Storage yesterday. You can now attach a block data volume from NetApp and Pure Storage systems to your EC2 instance running on Outpost right from the AWS Management Console. This allows you to quickly integrate and migrate your VMs to an EC2 instance on Outpost while continuing to use the advanced data management features provided by these industry-leading storage vendors. So very excited for this capability to be available. At the application layer, I'm also thrilled to share that PaaSX, which is a popular manufacturing execution system, MES, from Kuber Pharma, is now validated on Outpost with a multi-rack or a multi-outpost setup. When you deploy PaaSX MES on multiple racks within the same logical data center, PaaSX can benefit from the local Kubernetes control plane instances to manage databases and seamless failover to provide a robust failover mechanisms for critical MES workloads. When you deploy it in a multi-logical outpost, PaaS can leverage from synchronous RDS replication for databases, enabling data consistency and high availability. This active setup of PaaSX across multiple outposts allows you to fail over in the event of an outage at one of your locations. The two options help pharmaceutical companies achieve unparalleled reliability and scalability for their mission-critical applications and latency-sensitive MES workloads, while meeting strict regulatory requirements for having the data on-premise. Lastly, you can use a number of AWS native and third-party migration tools to facilitate migrations. In the interest of time, I won't go into details for these, but we have a session where our solution architects will deep dive into VMware migrations to Outposts with the use of these tools. So please make sure to go check that out. Next, let's switch gears to discuss how you can run regulated workloads on AWS hybrid and edge services to meet regulated digital sovereignty and data residency requirements. As the regulatory environment continues to evolve, many customers have shared with us that they are concerned that they'll have to choose between bespoke cloud solutions that could hamper their ability to innovate and transform. We firmly believe that customers shouldn't have to make this decision. That is why we introduced the AWS Digital Sovereignty Pledge, our commitment to offer all AWS customers the most advanced set of sovereignty controls and features available in the cloud. On hybrid and edge services aligned, our hybrid and edge services align with these 4 pillars of Digital Sovereignty Pledge, giving our customers more choice over the location of your data with the same controls and encryption capabilities regardless of where your data is stored. First, control over the location of your data. It is important to understand that data residency is not black and white. Instead, it's a spectrum with shades of complexity that vary from one scenario to another. Identifying in-scope data is a pivotal step that influences every aspect of a customer's design and investment need. In this slide, you can see some of the most common scenarios that our customers run into. We work backward from your country-specific regulatory and compliance needs, help you identify in-scope data, and recommend the right infrastructure offering that meets your specific needs, whether that is an AWS region, a local zone, or an outpost. Additionally, we can set up data residency guardrails to control the location and movement of your data, using the same tooling across region and hybrid and edge services like AWS Control Tower landing zones. Second, verifiable control over data access. In 2023, we've launched dedicated local zones as a type of infrastructure that is fully managed by AWS, built exclusively for the use of a customer or community, and placed in a customer-specified location or data center to run sensitive or regulated industry workloads. AWS works with customers to configure dedicated local zones with features to help meet their regulatory requirements. These include access to data, monitoring, auditing programs, controlling infrastructure access to customer accounts, and optional for AWS personnel who needs to work on the equipment to meet local clearance and security criteria. I'm excited to share, and you see on the screen here for a while now, the availability of 2 S3 storage classes for dedicated local zones. First, Amazon S3 Express One Zone, and then secondly, S3 One Zone Infrequently Access. In dedicated local zones, these storage classes are purpose-built to store data in a specific data perimeter, helping to support your data isolation and data residency use cases. You can enforce security within a data perimeter using AWS Identity and Access Management, organize and manage data with bucket tags, meet audit requirements with access logs in AWS CloudTrail, and meet encryption and standards with customer-managed keys with AWS Key Management Service for server-side encryption. Third, verifiable control over data access. Across our regions, our local zones, and our outposts, AWS infrastructure is powered by AWS Nitro system to help ensure the confidentiality and integrity of your customer data. For over 10 years, we have been reinventing the EC2 virtualization stack by moving virtualization functions, including security, network, storage, and compute to specialized and dedicated hardware and firmware called the Nitro system, and therefore removing the need of AWS to run software on the host CPU, memory, or disk where your customer workloads are running. By providing this strong physical and logical security boundary, Nitro is designed to enforce restrictions so that nobody, including anyone from AWS, can access customer workloads on EC2. A global security consulting firm, NCC Group, published an independent report on our security design claims of the Nitro system. It concluded that as a matter of design, NCC Group found no gaps in the Nitro system that would compromise these security claims. It also goes on to state, NCC Group, that there is no indication that a cloud service provider employee can obtain access to any host running on Nitro. To protect your data when removing Outpost Server from your data center, we have developed a Nitro security key found on every Outpost server that uses encryption that's used to encrypt all of the data on that outpost. Before an Outpost server ever leaves your data center, this Nitro security key is removed from the server, and using a hex key, the security chip containing the encryption keys are crushed, which cryptographically erase all of the data on that server. This ends up being an incredible, simple, elegant, but rigorous way of solving data destruction problems, simplifying data center operations, and help protect sensitive data from leaving customer data centers. This same Nitro key is also used in our local zones, and we are deploying this same key within our own data centers due to the simplicity of data destruction. Last but not least, as our CTO, Dr. Werner Vogel, once said, everything fails all the time. And this is especially true at the edge locations where temporary network disconnects happens due to fiber cuts or weather events. Therefore, we continue to invest in enhancing the resiliency of our hybrid and edge services. Today, I want to highlight a few significant enhancements that we have made to enhance the availability and survivability of workloads in our hybrid and edge services. First is intra-VPC communication across multiple outposts. This enables local connectivity between different logical outposts without having to traverse the parent region. Customers can take advantage of this enhancement to architect for high availability for their on-premise applications, at the same time improve the application performance by reducing the latency for not having to traverse across the region. Customers in regulated industries like government, defense, financial services, and industrial have also told us that they want the power of AWS in the most remote and geographic dispersed environments on Earth, but require a level of network resiliency that terrestrial connections don't currently provide. So, working with partners including Accenture, Andis, Capgemini, Deloitte, Kyndryl, and TCS, we have now a solution that can build satellite resiliency for AWS Outposts. This solution connects Outposts to low-orbit satellites, and if there is a disruption in terrestrial connectivity, it uses a smart network routing that routes the traffic to the parent region over satellite connection. Currently, the solution can be used as both a primary and a backup connection for Outpost servers, as well as a backup connection for Outpost racks. Now customers can greatly increase the resiliency of their network connectivity between Outposts and the region, or deploy Outposts in very remote locations. Earlier this year, we also announced an AWS Elastic Disaster Recovery support for local zones and Outposts. AWS RDS provides a native tool for you to simplify disaster recovery of workloads with Outposts or local zones as the destination. And right before reInvent, we also announced static stability for EC2 instances on Outpost, backed by instant store volumes. This enables automatic recovery from power failures or resets when the connection to the parent region is unavailable. It also allows the Outpost to continue to operate for an extended period of time without any connection to the parent region. In addition to enhancing the capabilities of our hybrid and edge services, we also continue to expand on the locations where you can leverage our cloud capabilities and distributed workloads. AWS has the largest global infrastructure footprint of any provider for distributed workloads, and this footprint constantly increases at a significant rate. And here's just a snapshot of our footprint as of today. In the past 12 months, we have added 5 more local zones in Atlanta, Chicago, Houston, Honolulu, and Miami. And we keep on adding new countries and territories for Outpost so we can ship and deploy across the world. In this year, we've announced availability of Outposts in Turkey, Jordan, the Kingdom of Saudi Arabia, Kuwait, and in Senegal. With Outpost availability in Kuwait, we have become the first major cloud provider to enable the use of cloud services in-country. Jaeger is among the first customers to leverage these cloud services in Kuwait using Outpost. Jaeger is a leading provider of cloud-based business automation technology specializing in procurement and supplier collaboration solutions, and now they can extend, already as an AWS user, their offerings to Kuwait for their customers and still comply with local regulations and requirements. To summarize a couple of key points of what we discussed today, with AWS, you can leverage the same infrastructure, the same APIs, management console, automation, governance policies, and security controls across cloud, on-premise, and edge environments. This consistent approach is what truly differentiates us from comparable solutions. And it's what allows you to boost developer productivity, improving IT efficiency, and eventually deliver innovative solutions to your customers faster. Secondly, AWS support a broad range of on-premise and edge workloads that require low latency, local data processing, and data residency requirements. This includes some of the workloads that were previously considered impossible to run in the cloud. We also bring AWS experience on-premise to help you accelerate migrations and modernization, including the VMware migrations that needs to remain on-premise. And finally, AWS is committed to continue our investment and innovation in the hybrid cloud and edge compute. And as Jeff mentioned, we are working on the smaller server. We are working on the disconnect. You saw the announcement with static stability there. And we will continue to invest so that we can bring AWS wherever you need it. And lastly, I will also recommend checking out some of the breakout sessions to our hybrid cloud and edge computing during reInvent. We also have quite a few chalk talks and workshops that takes you through the practical architecture patterns and implementations on the edge. You can also visit our booth and talk to our experts. This year, we are bringing a full set of all of our core hardware innovations to the booth, all of our custom design chips, our switches, our optical devices, fiber cabling systems, Outpost racks and devices, and certified IoT devices. So please make sure to go check them out all in our booth. You can also flex your muscle if you want to go see some Gen AI in action. Take a few basketball shots in the booth and experience how we can capture your moves and generate an AI-powered live commentary and sports highlight reel for you using Outposts, Inferentia, and ECS. Lastly, we will really appreciate if you could complete the session survey. That really helps us improve. And I hope you learned something today, and thank you for attending.